Physics by Aristotle. Book 8, Section 1. It remains to consider the following question. Was there ever a becoming of motion before which it had no being, and is it perishing again so as to leave nothing in motion? Or are we to say that it never had any becoming and is not perishing, but always was and always will be? Is it in fact an immortal, never-failing property of things that are, a sort of life, as it were, to all naturally constituted things? Now the existence of motion is asserted by all who have anything to say about nature, because they all concern themselves with the construction of the world, and study the question of becoming and perishing, which processes could not come about without the existence of motion. But those who say that there is an infinite number of worlds, some of which are in process of becoming, while others are in process of perishing, assert that there is always motion, for these processes of becoming and perishing of the worlds necessarily involve motion, whereas those who hold that there is only one world, whether everlasting or not, make corresponding assumptions in regard to motion. If then it is possible that at any time nothing should be in motion, this must come about in one of two ways. Either in the manner described by Anaxagoras, who says that all things were together and at rest for an infinite period of time, and that then mind introduced motion and separated them, or in the manner described by Empedocles, according to whom the universe is alternately in motion and at rest, in motion when love is making the one out of many, or strife is making many out of one, and at rest in the intermediate periods of time, his account being as follows. Since one hath learned to spring from manifold, and one disjoined makes manifold arise, thus they become, nor stable is their life. But since their motion must alternate be, thus have they ever rest upon their round. For we must suppose that he means by this that they alternate from the one motion to the other. We must consider then how this matter stands, for the discovery of the truth about it is of importance, not only for the study of nature, but also for the investigation of the first principle. Let us take our start from what we have already laid down in our course on physics. Motion, we say, is the fulfillment of the movable insofar as it is movable. Each kind of motion, therefore, necessarily involves the presence of the things that are capable of that motion. In fact, even apart from the definition of motion, everyone would admit that in each kind of motion it is that which is capable of that motion that is in motion. Thus it is that which is capable of alteration that is altered, and that which is capable of local change that is in locomotion, and so there must be something capable of being burned before there can be a process of being burned, and something capable of burning before there can be a process of burning. Moreover, these things also must either have a beginning before which they had no being, or they must be eternal. Now if there was a becoming of every movable thing, it follows that before the motion in question another change or motion must have taken place, in which that which was capable of being moved, or of causing motion, had its becoming. To suppose, on the other hand, that these things were in being throughout all previous time without there being any motion, appears unreasonable on a moment's thought, and still more unreasonable, we shall find, on further consideration. For if we are to say that, while there are on the one hand things that are movable, and on the other hand things that are motive, there is a time when there is a first movement, and a first moved, and another time when there is no such thing, but only something that is at rest, then this thing that is at rest must previously have been in process of change, for there must have been some cause of its rest before the privation of motion. Therefore, before this first change, there will be a previous change. For some things cause motion in only one way, while others can produce either of two contrary motions. Thus fire causes heating, but not cooling, whereas it would seem that knowledge may be directed to two contrary ends while remaining one and the same. Even in the former class, however, there seems to be something similar, for a cold thing in a sense causes heating by turning away and retiring, just as one possessed of knowledge voluntarily makes an error when he uses his knowledge in the reverse way. But at any rate, all things that are capable respectively of affecting and being affected, or of causing motion and being moved, are capable of it not under all conditions, but only when they are in a particular condition and approach one another. So it is on the approach of one thing to another that the one causes motion and the other is moved, and when they are present under such conditions as rendered the one motive and the other movable. So if the motion was not always in process, it is clear that they must have been in a condition not such as to render them capable respectively of being moved and of causing motion, and one or other of them must have been in process of change. For in what is relative, this is a necessary consequence. That is, if one thing is double another when before it was not so, one or other of them, if not both, must have been in process of change. It follows, then, that there will be a process of change previous to the first. Further, how can there be any before and after without the existence of time? Or how can there be any time without the existence of motion? If, then, time is the number of motion, or itself a kind of motion, it follows that, if there is always time, motion must also be eternal. But, so far as time is concerned, we see that all with one exception are in agreement in saying that it is uncreated. In fact, it is just this that enables Democritus to show that all things cannot have had a becoming. For time, he says, is uncreated. Plato alone asserts the creation of time, saying that it had a becoming together with the universe according to him having had a becoming. Now since time cannot exist and is unthinkable apart from the moment, and the moment a kind of middle point, uniting as it does in itself both a beginning and an end, a beginning of future time and an end of past time, it follows that there must always be time. For the extremity of the last period of time that we take must be found in some moment, since time contains no point of contact for us except the moment. Therefore, since the moment is both a beginning and an end, there must always be time on both sides of it. But if this is true of time, it is evident that it must also be true of motion, time being a kind of affection of motion. The same reasoning will also serve to show the imperishability of motion, just as a becoming of motion would involve, as we saw, the existence of a process of change previous to the first. In the same way a perishing of motion would involve the existence of a process of change subsequent to the last. For when a thing ceases to be moved, it does not therefore at the same time cease to be movable. For example, the cessation of the process of being burned does not involve the cessation of the capacity of being burned, since a thing may be capable of being burned without being in process of being burned, nor, when a thing ceases to be movement, does it therefore at the same time cease to be a motive. Again, the destructive agent will have to be destroyed after what it destroys has been destroyed, and then that which has the capacity of destroying it will have to be destroyed afterwards, so that there will be a process of change subsequent to the last, for being destroyed also is a kind of change. If then the view which we are criticizing involves these impossible consequences, it is clear that motion is eternal and cannot have existed at one time and not at another. In fact, such a view can hardly be described as anything else than fantastic. And much the same may be said of the view that such is the ordinance of nature, and that this must be regarded as a principle, as would seem to be the view of Empedocles when he says that the constitution of the world is of necessity such that love and strife alternately predominate and cause motion, while in the intermediate period of time there is a state of rest. Possibly also those who, like Anaxagoras, assert a single principle of motion would hold this view. But that which is produced or directed by nature can never be anything disorderly, for nature is everywhere the cause of order. Moreover, there is no ratio in the relation of the infinite to the infinite, whereas order always means ratio. But if we say that there is a first state of rest for an infinite time, and then motion is started at some moment, and that the fact that it is this rather than a previous moment is of no importance and involves no order, then we can no longer say that it is nature's work. For if anything is of a certain character naturally, it either is so invariably, and is not sometimes of this and sometimes of another character. For example, fire, which travels upwards naturally, does not sometimes do so and sometimes not, or there is a ratio in the variation. It would be better, therefore, to say with Empedocles, and anyone else who may have maintained such a theory as his, that the universe is alternately at rest and in motion. For in a system of this kind, we have at once a certain order. But even here the holder of the theory ought not only to assert the fact, he ought to explain the cause of it. That is, he should not make any mere assumption or lay down any gratuitous axiom, but should employ either inductive or demonstrative reasoning. The love and strife postulated by Empedocles are not in themselves causes of the fact in question, nor is it of the essence of either that it should be so, the essential function of the former being to unite, of the latter to separate. If he is to go on to explain this alternate predominance, he should adduce cases where such a state of things exists, as he points to the fact that among mankind we have something that unites men, namely love, while on the other hand enemies avoid one another. Thus, from the observed fact that this occurs in certain cases comes the assumption that it occurs also in the universe. Then again, some argument is needed to explain why the predominance of each of the two forces lasts for an equal period of time. But it is a wrong assumption to suppose universally that we have an adequate first principle in virtue of the fact that something always is so or always happens so. Thus Democritus reduces the causes that explain nature to the fact that things happened in the past in the same way as they happen now. But he does not think it fit to seek for a first principle to explain this always. So, while his theory is right insofar as it is applied to certain individual cases, he is wrong in making it of universal application. Thus, a triangle always has its angles equal to two right angles, but there is nevertheless an ulterior cause of the eternity of this truth, whereas first principles are eternal and have no ulterior cause. Let this conclude what we have to say in support of our contention that there never was a time when there was not motion, and never will be a time when there will not be motion. Section 2. The arguments that may be advanced against this position are not difficult to dispose of. The chief considerations that might be thought to indicate that motion may exist, though at one time it had not existed at all, are the following. First, it may be said that no process of change is eternal, for the nature of all change is such that it proceeds from something to something, so that every process of change must be bounded by the contraries that mark its course, and no motion can go on to infinity. Secondly, we see that a thing that neither is in motion nor contains any motion within itself can be set in motion. For example, inanimate things that are, whether the whole or some part is in question, not in motion but at rest, are at some moment set in motion. Whereas if motion cannot have a becoming before which it had no being, these things ought to be either always or never in motion. Thirdly, the fact is evident above all in the case of animate beings, for it sometimes happens that there is no motion in us and we are quite still, and that, nevertheless, we are then at some moment set in motion. That is to say, it sometimes happens that we produce a beginning of motion in ourselves spontaneously without anything having set us in motion from without. We see nothing like this in the case of inanimate things, which are always set in motion by something else from without. The animal, on the other hand, we say, moves itself. Therefore, if an animal is ever in a state of absolute rest, we have a motionless thing in which motion can be produced from the thing itself and not from without. Now, if this can occur in an animal, why should not the same be true also of the universe as a whole? If it can occur in a small world, it could also occur in a great one, and if it can occur in the world, it could also occur in the infinite. That is, if the infinite could as a whole possibly be in motion or at rest. Of these objections, then, the first mentioned motion to opposites is not always the same and numerically one a correct statement. In fact, this may be said to be a necessary conclusion, provided that it is possible for the motion of that which is one and the same to be not always one and the same. I mean that, for example, we may question whether the note given by a single string is one and the same, or is different each time the string is struck, although the string is in the same condition and is moved in the same way. But still, however this may be, there is nothing to prevent there being a motion that is the same in virtue of being continuous and eternal. We shall have something to say later that will make this point clearer. As regards the second objection, no absurdity is involved in the fact that something not in motion may be set in motion, that which caused the motion from without being at one time present and at another absent. Nevertheless, how this can be so remains matter for inquiry. How it comes about, I mean that the same motive force at one time causes a thing to be in motion and at another does not do so, for the difficulty raised by our objector really amounts to this. Why is it that some things are not always at rest and the rest always in motion? The third objection may be thought to present more difficulty than the others, namely, that which alleges that motion arises in things in which it did not exist before, and adduces in proof the case of animate things. Thus, an animal is first at rest, and afterwards walks, not having been set in motion apparently by anything from without. This, however, is false, for we observe that there is always some part of the animal's organism in motion, and the cause of the motion of this part is not the animal itself, but it may be its environment. Moreover, we say that the animal itself originates not all of its motions, but its locomotion. So it may well be the case, or rather, we may perhaps say that it must necessarily be the case, that many motions are produced in the body by its environment, and some of these set in motion the intellect or the appetite, and this again then sets the whole animal in motion. This is what happens when animals are asleep. Though there is no perceptive motion in them, there is some motion that causes them to wake up again. But we will leave this point also to be elucidated at a later stage in our discussion. Section 3. Our enquiry will resolve itself at the outset into a consideration of the above-mentioned problem: what can be the reason why some things in the world at one time are in motion, and at another are at rest again? Now, one of three things must be true. Either all things are always at rest, or all things are always in motion, or some things are in motion and others at rest, and in this last case, again, either the things that are in motion are always in motion, and the things that are at rest are always at rest, or they are all constituted so as to be capable alike of motion and of rest. Or there is yet a third possibility remaining. It may be that some things in the world are always motionless, others always in motion, while others again admit of both conditions. This last is the account of the matter that we must give, for herein lies the solution of all the difficulties raised and the conclusion of the investigation upon which we are engaged. To maintain that all things are at rest, and to disregard sense perception in an attempt to show the theory to be reasonable, would be an instance of intellectual weakness. It would call in question a whole system, not a particular detail. Moreover, it would be an attack not only on the physicist, but on almost all sciences and all received opinions, since motion plays a part in all of them. Further, just as in arguments about mathematics, objections that involve first principles do not affect the mathematician, and the other sciences are in similar case so, too, objections involving the point that we have just raised do not affect the physicist, for it is a fundamental assumption with him that motion is ultimately referable to nature herself. The assertion that all things are in motion we may fairly regard as equally false, though it is less subversive of physical science. For though in our course on physics it was laid down that rest, no less than motion, is ultimately referable to nature herself, nevertheless, motion is the characteristic fact of nature. Moreover, the view is actually held by some that not merely some things, but all things in the world are in motion, and always in motion, though we cannot apprehend the fact by sense perception. Although the supporters of this theory do not state clearly what kind of motion they mean, or whether they mean all kinds, it is no hard matter to reply to them. Thus, we may point out that there cannot be a continuous process either of increase or of decrease. That which comes between the two has to be included. The theory resembles that about the stone being worn away by the drop of water, or split by plants growing out of it. If so much has been extruded or removed by the drop, it does not follow that half the amount has previously been extruded or removed in half the time. The case of the hauled ship is exactly comparable. Here we have so many drops setting so much in motion, but a part of them will not set as much in motion in any period of time. The amount removed is, it is true, divisible into a number of parts, but no one of these was set in motion separately. They were all set in motion together. It is evident, then, that from the fact that the decrease is divisible into an infinite number of parts, it does not follow that some part must always be passing away. It all passes away at a particular moment. Similarly, too, in the case of any alteration whatever, if that which suffers alteration is infinitely divisible, it does not follow from this that the same is true of the alteration itself, which often occurs all at once, as in freezing. Again, when anyone has fallen ill, there must follow a period of time in which his restoration to health is in the future. The process of change cannot take place in an instant, yet the change cannot be a change to anything else but health. The assertion, therefore, that alteration is continuous is an extravagant calling into question of the obvious, for alteration is a change from one contrary to another. Moreover, we notice that a stone becomes neither harder nor softer. Again, in the matter of locomotion, it would be a strange thing if a stone could be falling or resting on the ground without our being able to perceive the fact. Further, it is a law of nature that earth and all other bodies should remain in their proper places and be moved from them only by violence. From the fact, then, that some of them are in their proper places, it follows that in respective place also all things cannot be in motion. These and other similar arguments, then, should convince us that it is impossible either that all things are always in motion, or that all things are always at rest. Nor again can it be that some things are always at rest, others always in motion, and nothing sometimes at rest and sometimes in motion. This theory must be pronounced impossible on the same grounds as those previously mentioned, namely, that we see the above-mentioned changes occurring in the case of the same things. We may further point out that the defender of this position is fighting against the obvious, for on this theory there can be no such thing as increase, nor can there be any such thing as compulsory motion, if it is impossible that a thing can be at rest before being set in motion unnaturally. This theory, then, does away with becoming and perishing. Moreover, motion, it would seem, is generally thought to be a sort of becoming and perishing, for that to which a thing changes comes to be, or occupancy of it comes to be, and that from which a thing changes ceases to be, or there ceases to be occupancy of it. It is clear, therefore, that there are cases of occasional motion and occasional rest. We have now to take the assertion that all things are sometimes at rest and sometimes in motion, and to confront it with the arguments previously advanced. We must take our start, as before, from the possibilities that we distinguished just above. Either all things are at rest, or all things are in motion, or some things are at rest and others in motion. And if some things are at rest and others in motion, then it must be that either all things are sometimes at rest and sometimes in motion, or some things are always at rest and the remainder always in motion, or some of the things are always at rest and others always in motion, while others again are sometimes at rest and sometimes in motion. Now we have said before that it is impossible that all things should be at rest. Nevertheless, we may now repeat that assertion. We may point out that, even if it is really the case, as certain persons assert, that the existent is infinite and motionless, it certainly does not appear to be so if we follow sense perception. Many things that exist appear to be in motion. Now, if there is such a thing as false opinion, or opinion at all, there is also motion. And similarly, if there is such a thing as imagination, or if it is the case that anything seems to be different at different times, for imagination and opinion are thought to be motions of a kind, but to investigate this question at all, to seek a reasoned justification of a belief with regard to which we are too well off to require reasoned justification, implies bad judgment of what is better and what is worse, what commends itself to belief and what does not, what is ultimate and what is not. It is likewise impossible that all things should be in motion, or that some things should be always in motion and the remainder always at rest. We have sufficient ground for rejecting all these theories in the single fact that we see some things that are sometimes in motion and sometimes at rest. It is evident, therefore, that it is no less impossible that some things should be always in motion and the remainder always at rest, than that all things should be at rest, or that all things should be in motion continuously. It remains then to consider whether all things are so constituted as to be capable both of being in motion and of being at rest, or whether, while some things are so constituted, some are always at rest and some are always in motion. For it is this last view that we have to show to be true. Section 4. Now, of things that cause motion or suffer motion, to some the motion is accidental, to others essential. Thus, it is accidental to what merely belongs to or contains as a part of a thing that causes motion or suffers motion, essential to a thing that causes motion or suffers motion not merely by belonging to such a thing or containing it as a part. Of things to which the motion is essential, some derive their motion from themselves, others from something else, and in some cases their motion is natural, in others violent and unnatural. Thus in things that derive their motion from themselves, for example, all animals, the motion is natural, for when an animal is in motion, its motion is derived from itself, and whenever the source of the motion of a thing is in the thing itself, we say that the motion of that thing is natural. Therefore, the animal as a whole moves itself naturally. But the body of the animal may be in motion unnaturally as well as naturally. It depends upon the kind of motion that it may chance to be suffering, and the kind of element of which it is composed. and the motion of things that derive their motion from something else is in some cases natural, in other unnatural. For example, upward motion of earthly things and downward motion of fires are unnatural. Moreover, the parts of animals are often in motion in an unnatural way, their positions and the character of the motion being abnormal. The fact that a thing that is in motion derives its motion from something is most evident in things that are in motion unnaturally, because in such cases it is clear that the motion is derived from something other than the thing itself. Next to things that are in motion unnaturally, those whose motion while natural is derived from themselves, for example, animals, make this fact clear. For here the uncertainty is not as to whether the motion is derived from something, but as to how we ought to distinguish in the thing between the movement and the moved. It would seem that in animals, just as in ships and things not naturally organized, that which causes motion is separate from that which suffers motion, and that it is only in this sense that the animal as a whole causes its own motion. The greatest difficulty, however, is presented by the remaining case of those that we last distinguished. Where things derive their motion from something else, we distinguished the cases in which the motion is unnatural. We are left with those that are to be contrasted with the others by reason of the fact that the motion is natural. It is in these cases that difficulty would be experienced in deciding whence the motion is derived. For example, in the case of light and heavy things. When these things are in motion to positions the reverse of those they would properly occupy, their motion is violent. When they are in motion to their proper positions, the light thing up and the heavy thing down, their motion is natural. But in this latter case, it is no longer evident, as it is when the motion is unnatural, whence their motion is derived. It is impossible to say that their motion is derived from themselves. This is a characteristic of life and peculiar to living things. Further, if it were, it would have been in their power to stop themselves. I mean that if, for example, a thing can cause itself to walk, it can also cause itself not to walk. And so, since on this supposition fire itself possesses the power of upward locomotion, it is clear that it should also possess the power of downward locomotion. Moreover, if things move themselves, it would be unreasonable to suppose that in only one kind of motion is their motion derived from themselves. Again, how can anything of continuous and naturally connected substance move itself? In so far as a thing is one and continuous, not merely in virtue of contact, it is impassive. It is only in so far as a thing is divided that one part of it is by nature active and another passive. Therefore, none of the things that we are now considering move themselves, for they are of naturally connected substance, nor does anything else that is continuous. In each case the movement must be separate from the moved, as we see to be the case with inanimate things when an animate thing moves them. It is the fact that these things also always derive their motion from something. What it is would become evident if we were to distinguish the different kinds of cause. The above-mentioned distinctions can also be made in the case of things that cause motion. Some of them are capable of causing motion unnaturally. For example, the lever is not naturally capable of moving the weight. Others, naturally. For example, what is actually hot is naturally capable of moving what is potentially hot, and similarly in the case of all other things of this kind. In the same way, too, what is potentially of a certain quality or of a certain quantity in a certain place is naturally movable when it contains the corresponding principle in itself, and not accidentally, for the same thing may be both of a certain quality and of a certain quantity, but the one is an accidental, not an essential property of the other. So when fire or earth is moved by something, the motion is violent, when it is unnatural, and natural when it brings to actuality the proper activities that they potentially possess. But the fact that the term potentially is used in more than one sense is the reason why it is not evident whence such motions as the upward motion of fire and the downward motion of earth are derived. One who is learning a science potentially knows it in a different sense from one who, while already possessing the knowledge, is not actually exercising it. Wherever we have something capable of acting and something capable of being correspondingly acted on, in the event of any such pair being in contact, what is potential becomes at times actual. For example, the learner becomes from one potential something another potential something. For one who possesses knowledge of a science but is not actually exercising it knows the science potentially in a sense, though not in the same sense as he knew it potentially before he learnt it. And when he is in this condition, if something does not prevent him, he actively exercises his knowledge. Otherwise, he would be in the contradictory state of not knowing. In regard to natural bodies, also the case is similar. Thus, what is cold is potentially hot. Then a change takes place, and it is fire, and it burns, unless something prevents and hinders it. So, too, with heavy and light. Light is generated from heavy, for example, air from water, for water is the first thing that is potentially light, and air is actually light, and will at once realize its proper activity as such unless something prevents it. The activity of lightness consists in the light thing being in a certain situation, namely high up. When it is in the contrary situation, it is prevented from rising. The case is similar also in regard to quantity and quality. But, be it noted, this is the question we are trying to answer. How can we account for the motion of light things and heavy things to their proper situations? The reason for it is that they have a natural tendency respectively towards a certain position, and this constitutes the essence of lightness and heaviness, the former being determined by an upward, the latter by a downward tendency. As we have said, a thing may be potentially light or heavy in more senses than one. Thus, not only when a thing is water is it, in a sense, potentially light, but when it has become air it may be still potentially light. For it may be that, through some hindrance, it does not occupy an upper position, whereas if what hinders it is removed, it realizes its activity and continues to rise higher. The process whereby what is of a certain quality changes to a condition of active existence is similar. Thus, the exercise of knowledge follows at once upon the possession of it, unless something prevents it. So, too, what is of a certain quantity extends itself over a certain space, unless something prevents it. The thing in a sense is, and in a sense is not, moved by one who moves what is obstructing and preventing its motion. For example, one who pulls away a pillar from under a roof, or one who removes a stone from a wineskin in the water, is the accidental cause of motion. And in the same way the real cause of the motion of a ball rebounding from a wall is not the wall, but the thrower. So it is clear that in all these cases the thing does not move itself, but it contains within itself the source of motion, not of moving something or of causing motion, but of suffering it. If then the motion of all things that are in motion is either natural or unnatural and violent, and all things whose motion is violent and unnatural are moved by something, and something other than themselves, and again all things whose motion is natural are moved by something, both those that are moved by themselves and those that are not moved by themselves, for example, light things and heavy things, which are moved either by that which brought the thing into existence as such and made it light and heavy, or by that which released what was hindering and preventing it, then all things that are in motion must be moved by something. Section 5. Now this may come about in either of two ways. Either the movement is not itself responsible for the motion, which is to be referred to something else which moves the movement, or the movement is itself responsible for the motion. Further, in the latter case, either the movement immediately precedes the last thing in the series, or there may be one or more intermediate links. For example, the stick moves the stone and is moved by the hand, which again is moved by the man. In the man, however, we have reached a movement that is not so in virtue of being moved by something else. Now we say that the thing is moved both by the last and by the first movement in the series, but more strictly by the first, since the first movement moves the last, whereas the last does not move the first, and the first will move the thing without the last, but the last will not move it without the first. For example, the stick will not move anything unless it is itself moved by the man. If then everything that is in motion must be moved by something, and the movement must either itself be moved by something else or not, and in the former case there must be some first movement that is not itself moved by anything else, while in the case of the immediate movement being of this kind, there is no need of an intermediate movement that is also moved, for it is impossible that there should be an infinite series of movements, each of which is itself moved by something else, since in an infinite series there is no first term. If then everything that is in motion is moved by something, and the first movement is moved, but not by anything else, it must be moved by itself. This same argument may also be stated in another way as follows. Every movement moves something and moves it with something, either with itself or with something else. For example, a man moves a thing either himself or with a stick, and a thing is knocked down either by the wind itself or by a stone propelled by the wind. But it is impossible for that with which a thing is moved to move it without being moved by that which imparts motion by its own agency. On the other hand, if a thing imparts motion by its own agency, it is not necessary that there should be anything else with which it imparts motion, whereas if there is a different thing with which it imparts motion, there must be something that imparts motion not with something else, but with itself, or else there will be an infinite series. If, then, anything is a movement while being itself moved, the series must stop somewhere and not be infinite. Thus, if the stick moves something in virtue of being moved by the hand moves the stick, and if something else moves with the hand also is moved by something different from itself. So when motion by means of an instrument is at each stage caused by something different from the instrument, this must always be preceded by something else, which imparts motion with itself. Therefore, if this last movement is in motion, and there is nothing else that moves it, it must move itself. So, this reasoning also shows that when a thing is moved, if it is not moved immediately by something that moves itself, the series brings us at some time or other to a movement of this kind. And if we consider the matter in yet a third way, we shall get this same result as follows. If everything that is in motion is moved by something that is in motion, either this being in motion is an accidental attribute of the movements in question, so that each of them moves something while being itself in motion, but not always because it is itself in motion, or it is not accidental, but an essential attribute. Let us consider the former alternative. If then it is an accidental attribute, it is not necessary that that is in motion should be in motion. And if this is so, it is clear that there may be a time when nothing that exists is in motion, since the accidental is not necessary but contingent. Now, if we assume the existence of a possibility, any conclusion that we thereby reach will not be an impossibility, though it may be contrary to fact. But the non-existence of motion is an impossibility, for we have shown above that there must always be motion. Moreover, the conclusion to which we have been led is a reasonable one, for there must be three things, the moved, the movement, and the instrument of motion. Now the moved must be in motion, but it need not move anything else. The instrument of motion must both move something else and be itself in motion, for it changes together with the moved, with which it is in contact and continuous, as is clear in the case of things that move other things locally, in which case the two things must up to a certain point be in contact. And the movement, that is to say, that which causes motion in such a manner that it is not merely the instrument of motion, must be unmoved. Now, we have visual experience of the last term in this series, namely that which has the capacity of being in motion, but does not contain a motive principle, and also of that which is in motion, but is moved by itself and not by anything else. It is reasonable, therefore, not to say necessary, to suppose the existence of the third term also, that which causes motion, but is itself unmoved. So, too, Anaxagoras is right when he says that mind is impassive and unmixed, since he makes it the principle of motion. For it could cause motion in this sense only by being itself unmoved, and have supreme control only by being unmixed. We will now take the second alternative. If the movement is not accidentally, but necessarily in motion, so that, if it were not in motion, it would not move anything, then the movement, insofar as it is in motion, must be in motion in one of two ways. It is moved either as that is which is moved with the same kind of motion, or with a different kind, either that which is heating, is itself in process of becoming hot, that which is making healthy in process of becoming healthy, and that which is causing locomotion in process of locomotion, or else that which is making healthy is, let us say, in process of locomotion, and that which is causing locomotion in process of, say, increase. But it is evident that this is impossible. For if we adopt the first assumption, we have to make it apply within each of the very lowest species into which motion can be divided. For example, we must say that if someone is teaching some lesson in geometry, he is also in process of being taught that same lesson in geometry, and that if he is throwing, he is in process of being thrown in just the same manner. Or, if we reject this assumption, we must say that one kind of motion is derived from another. For example, that which is causing locomotion is in process of increase. That which is causing this increase is in process of being altered by something else, and that which is causing this alteration is in process of suffering some different kind of motion. But the series must stop somewhere, since the kinds of motion are limited. And if we say that the process is reversible, and that which is causing alteration is in process of locomotion, we do no more than if we had said at the outset that which is causing locomotion is in process of locomotion, and that one who is teaching is in process of being taught. For it is clear that everything that is moved by the movement that is further back in the series, as well as by that which immediately moves it. In fact, the earlier movement is that which more strictly moves it. But this is, of course, impossible, for it involves the consequence that one who is teaching is in process of learning what he is teaching, whereas teaching necessarily implies possessing knowledge, and learning not possessing it. Still more unreasonable is the consequence involved that, since everything that is moved by something that is itself moved by something else, everything that has a capacity for causing motion has, as such, a corresponding capacity for being moved. That is, it will have a capacity for being moved in the sense in which one might say that everything that has a capacity for making healthy and exercises that capacity has, as such, a capacity for being made healthy, and that which has a capacity for building has as such a capacity for being built. It will have the capacity for being thus moved either immediately or through one or more links, as it will if, while everything that has a capacity for causing motion has as such a capacity for being moved by something else, the motion that it has the capacity for suffering is not that with which it affects what is next to it, but a motion of a different kind. For example, that which has a capacity for making healthy might as such have a capacity for learning. The series, however, could be traced back, as we said before, until at some time or other we arrived at the same kind of motion. Now, the first alternative is impossible, and the second is fantastic. It is absurd that that which has a capacity for causing alteration should as such necessarily have a capacity, let us say, for increase. It is not necessary, therefore, that that which is moved should always be moved by something else that is itself moved by something else, so there will be an end to the series. Consequently, the first thing that is in motion will derive its motion either from something that is at rest or from itself. But if there were any need to consider which of the two, that which moves itself or that which is moved by something else, is the cause and principle of motion, every one would decide the former, for that which is itself independently a cause is always prior as a cause to that which is so only in virtue of being itself dependent upon something else that makes it so. We must therefore make a fresh start and consider the question: if a thing moves itself, in what sense and in what manner does it do so? Now, everything that is in motion must be infinitely divisible, for it has been shown already in our general course on physics that everything that is essentially in motion is continuous. Now, it is impossible that that which moves itself should in its entirety move itself, for then, while being specifically one and indivisible, it would as a whole both undergo and cause the same locomotion or alteration. Thus it would at the same time be both teaching and being taught the same thing, or both restoring to and being restored to the same health. Moreover, we have established the fact that it is the movable that is moved, and this is potentially, not actually, in motion, but the potential is in process to actuality, and motion is an incomplete actuality of the movable. The movement, on the other hand, is already in activity. That is, it is that which is hot that produces heat. In fact, that which produces the form is always something that possesses it. Consequently, if a thing can move itself as a whole, the same thing in respect of the same thing may be at the same time both hot and not hot. So too in every other case where the movement must be described by the same name in the same sense as the moved. Therefore, when a thing moves itself, it is one part of it that is the movement and another part that is moved. But it is not self-moving in the sense that each of the two parts is moved by the other part. The following considerations make this evident. In the first place, if each of the two parts is to move the other, there will be no first movement. If a thing is moved by a series of movements, that which is earlier in the series is more the cause of its being moved than that which comes next, and will be more truly the movement. For we found that there are two kinds of movement, that which is itself moved by something else, and that which derives its motion from itself. And that which is further from the thing that is moved is nearer to the principle of motion than that which is intermediate. In the second place, there is no necessity for the movement part to be moved by anything but itself. So it can only be accidentally that the other part moves it in return. I take then the possible case of its not moving it. Then there would be a part that is moved and a part that is an unmoved movement. In the third place, there is no necessity for the movement to be moved in return. On the contrary, the necessity that there should always be motion makes it necessary that there should be some movement that is either unmoved or moved by itself. In the fourth place, we should then have a thing undergoing the same motion that it is causing, that which is producing heat, therefore being heated. But as a matter of fact, that which primarily moves itself cannot contain either a single part that moves itself or a number of parts, each of which moves itself. For if the whole is moved by itself, it must be moved either by some part of itself, or as a whole by itself as a whole. If then it is moved in virtue of some part of it being moved by that part itself, It is this part that will be the primary self-movement, since, if this part is separated from the whole, the part will still move itself, but the whole will do so no longer. If, on the other hand, the whole is moved by itself as a whole, it must be accidentally that the parts move themselves, and therefore, their self-motion not being necessary, we may take the case of their not being moved by themselves. Therefore, in the whole of the thing we may distinguish that which imparts motion without itself being moved, and that which is moved, for only in this way is it possible for a thing to be self-moved. Further, if the whole moves itself, we may distinguish in it that which imparts the motion, and that which is moved. So while we say that AB is moved by itself, we may also say that it is moved by A. And since that which imparts motion may be either a thing that is moved or something else, or a thing that is unmoved, and that which is moved may be either a thing that imparts motion to something else, or a thing that does not, that which moves itself must be composed of something that is unmoved but imparts motion, and also of something that is moved but does not necessarily impart motion, but may or may not do so. Thus, let A be something that imparts motion but is unmoved, B something that is moved by A and moves, G something that is moved by B but moves nothing. Granted that we eventually arrive at G, we may take it that there is only one intermediate term, though there may be more. Then the whole, ABG, moves itself. But if I take away G, AB will move itself, A imparting motion and B being moved, whereas G will not move itself, or in fact be moved at all. Nor again will BG move itself apart from A, for B imparts motion only through being moved by something else, not through being moved by any part of itself. So only AB moves itself. That which moves itself, therefore, must comprise something that imparts motion but is unmoved, and something that is moved but does not necessarily move anything else. And each of these two things, or at any rate one of them, must be in contact with the other. If then that which imparts motion is a continuous substance, that which is moved must of course be, so it is clear, that it is not through some part of the whole being of such a nature as to be capable of moving itself that the whole moves itself. It moves itself as a whole, both being moved and imparting motion, through containing a part that imparts motion and a part that is moved. It does not impart motion as a whole, nor is it moved as a whole. It is A alone that imparts motion, and B alone that is moved. It is not true further that G is moved by A, which is impossible. Here a difficulty arises. If something is taken away from A, supposing that that which imparts motion but is unmoved is a continuous substance, or from B, the part that is moved, will the remainder of A continue to impart motion, or the remainder of B continue to be moved? If so, it will not be AB primarily that is moved by itself, since when something is taken away from AB, the remainder of AB will still continue to move itself. Perhaps we may state the case thus. There is nothing to prevent each of the two parts, or at any rate one of them, that which is moved, being divisible, though actually undivided, so that, if it is divided, it will not continue in the possession of the same capacity. And so there is nothing to prevent self-motion residing primarily in things that are potentially divisible. From what has been said, then, it is evident that that which primarily imparts motion is unmoved, for, whether the series is closed at once by that which is in motion but moved by something else deriving its motion directly from the first unmoved, or whether the motion is derived from what is in motion, but moves itself and stops its own motion, on both suppositions we have the result that in all cases of things being in motion, that which primarily imparts motion is unmoved. Section 6. Since there must always be motion without intermission, there must necessarily be something, one thing, or it may be a plurality, that first imparts motion, and this first movement must be unmoved. Now the question whether each of the things that are unmoved but impart motion is eternal is irrelevant to our present argument. But the following considerations will make it clear that there must necessarily be some such thing which, while it has the capacity of moving something else, is itself unmoved and exempt from all change which can affect it neither in an unqualified nor in an accidental sense. Let us suppose, if anyone likes, that in the case of certain things it is possible for them at different times to be and not to be, without any process of becoming and perishing. In fact, it would seem to be necessary, if a thing that has not parts at one time is and at another time is not, that any such thing should, without undergoing any process of change, at one time be and at another time not be. And let us further suppose it possible that some principles that are unmoved but capable of imparting motion at one time are, and at another time are not. Even so, this cannot be true of all such principles, since there must clearly be something that causes things that move themselves at one time to be and at another not to be. For, since nothing that has not parts can be in motion, that which moves itself must as a whole have magnitude, though nothing that we have said makes this necessarily true of every movement. So the fact that some things become and others perish, and that this is so continuously, cannot be caused by any one of those things that, though they are unmoved, do not always exist. Nor again can it be caused by any of those which move certain particular things, while others move other things. The eternity and continuity of the process cannot be caused either by any one of them singly, or by the sum of them, because this causal relation must be eternal and necessary, whereas the sum of these movements is infinite, and they do not all exist together. It is clear, then, that though there may be countless instances of the perishing of some principles that are unmoved, but impart motion, and though many things that move themselves perish and are succeeded by others that come into being, and though one thing that is unmoved moves one thing while another moves another, nevertheless there is something that comprehends them all, and that is something apart from each one of them, and this it is that is the cause of the fact that some things are and others are not, and of the continuous process of change. And this causes the motion of the other movements, while they are the causes of the motion of other things. Motion, then, being eternal, the first movement, if there is but one, will be eternal also. If there are more than one, there will be a plurality of such eternal movements. We ought, however, to suppose that there is one rather than many, and a finite rather than an infinite number. When the consequences of either assumption are the same, we should always assume that things are finite rather than infinite in number, since in things constituted by nature that which is finite and that which is better ought, if possible, to be present rather than the reverse. And here it is sufficient to assume only one movement, the first of unmoved things, which being eternal will be the principle of motion to everything else. The following argument also makes it evident that the first movement must be something that is one and eternal. We have shown that there must always be motion. That being so, motion must also be continuous, because what is always is continuous, whereas what is merely in succession is not continuous. But further, if motion is continuous, it is one, and it is one only if the movement and the moved that constitute it are each of them one, since in the event of a thing's being moved now by one thing and now by another, the whole motion will not be continuous but successive. Moreover, a conviction that there is a first unmoved something may be reached not only from the foregoing arguments, but also by considering again the principles operative in movements. Now, it is evident that among existing things there are some that are sometimes in motion and sometimes at rest. This fact has served above to make it clear that it is not true either that all things are in motion or that all things are at rest, or that some things are always at rest and the remainder always in motion. On this matter, proof is supplied by things that fluctuate between the two and have the capacity of being sometimes in motion and sometimes at rest. The existence of things of this kind is clear to all, but we wish to explain also the nature of each of the other two kinds, and show that there are some things that are always unmoved, and some things that are always in motion. In the course of our argument directed to this end, we established the fact that everything that is in motion is moved by something, and that the movement is either unmoved or in motion, and that, if it is in motion, it is moved either by itself or by something else, and so on throughout the series. And so we proceeded to the position that the first principle that directly causes things that are in motion to be moved is that which moves itself, and the first principle of the whole series is the unmoved. Further, it is evident from actual observation that there are things that have the characteristic of moving themselves, for example, the animal kingdom and the whole class of living things. This being so, then, the view was suggested that perhaps it may be possible for motion to come to be in a thing without having been in existence at all before, because we see this actually occurring in animals. They are unmoved at one time, and then again they are in motion, as it seems. We must grasp the fact, therefore, that animals move themselves only with one kind of motion, and that this is not strictly originated by them. The cause of it is not derived from the animal itself. It is connected with other natural motions in animals, which they do not experience through their own instrumentality. For example, increase, decrease, and respiration. These are experienced by every animal while it is at rest, and not in motion in respect of the motion set up by its own agency. Here the motion is caused by the atmosphere, and by many things that enter into the animal. Thus, in some cases, the cause is nourishment. When it is being digested, animals sleep, and when it is being distributed through the system, they awake and move themselves, the first principle of this motion being thus originally derived from outside. Therefore, animals are not always in continuous motion by their own agency. It is something else that moves them, itself being in motion and changing as it comes into relation with each several thing that moves itself. Moreover, in all these self-moving things, the first movement and cause of their self-motion is itself moved by itself, though in an accidental sense. That is to say, the body changes its place so that that which is in the body changes its place also, and is a self-movement through its exercise of leverage. Hence we may confidently conclude that if a thing belongs to the class of unmoved movements that are also themselves moved accidentally, it is impossible that it should cause continuous motion. So the necessity that there should be motion continuously requires that there should be a first movement that is unmoved, even accidentally, if, as we have said, there is to be in the world of things an unceasing and undying motion, and the world is to remain permanently self-contained and within the same limits. For if the first principle is permanent, the universe must also be permanent, since it is continuous with the first principle. We must distinguish, however, between accidental motion of a thing by itself and such motion by something else, the former being confined to perishable things, whereas the latter belongs also to certain first principles of heavenly bodies, of all those, that is to say, that experience more than one locomotion. And further, if there is always something of this nature, of movement that is itself unmoved and eternal, then that which is first moved by it must be eternal. Indeed, this is clear also from the consideration that there would otherwise be no becoming and perishing, and no change of any kind in other things which require something that is in motion to move them, for the motion imparted by the unmoved will always be imparted in the same way, and be one and the same, since the unmoved does not itself change in relation to that which is moved by it. But that which is moved by something that, though it is in motion, is moved directly by the unmoved stands in varying relations to the things that it moves, so that the motion that it causes will not be always the same, by reason of the fact that it occupies contrary positions or assumes contrary forms at different times. It will produce contrary motions in each several thing that it moves, and will cause it to be at one time at rest, at another time in motion. The foregoing argument, then, has served to clear up the point about which we raised a difficulty at the outset. Why is it that instead of all things being either in motion or at rest, or some things being always in motion and the remainder always at rest, there are things that are sometimes in motion and sometimes not? The cause of this is now plain. It is because, while some things are moved by an eternal unmoved movement, and are therefore always in motion, other things are moved by a movement that is in motion and changing, so that they too must change. But the unmoved movement, as has been said, since it remains permanently simple and unvarying and in the same state, will cause motion that is one and simple. Section 7. This matter will be made clearer, however, if we start afresh from another point. We must consider whether it is or is not possible that there should be a continuous motion, and, if it is possible, which this motion is, and which is the primary motion. For it is plain that if there must always be motion, and a particular motion is primary and continuous, then it is this motion that is imparted by the first movement, and so it is necessarily one and the same, and continuous, and primary. Now, of the three kinds of motion that there are, motion in respect of magnitude, motion in respect of affection, and motion in respect of place, it is this last which we call locomotion that must be primary. This may be shown as follows. It is impossible that there should be increase without the previous occurrence of alteration, for that which is increased, although in a sense it is increased by what is like itself, is in a sense increased by what is unlike itself. Thus it is said that contrary is nourishment to contrary. But growth is effected only by things becoming like to like. There must be alteration, then, in that there is this change from contrary to contrary. But the fact that a thing is altered requires that there should be something that alters it, something, for example, that makes the potentially hot into the actually hot. So it is plain that the movement does not maintain a uniform relation to it, but is at one time nearer to, and at another time farther from, that which is altered. And we cannot have this without locomotion. If, therefore, there must always be motion, there must always also be locomotion as the primary motion, and if there is a primary as distinguished from a secondary form of locomotion, it must be the primary form. Again, all affections have their origin in condensation and rarefaction. Thus, heavy and light, soft and hard, hot and cold, are considered to be forms of density and rarity. But condensation and rarefaction are nothing more than combination and separation, processes in accordance with which substances are said to become and perish, and in being combined and separated things must change in respect of place. And further, when a thing is increased or decreased, its magnitude changes in respect of place. Again, there is another point of view from which it will be clearly seen that locomotion is primary. As in the case of other things, so too in the case of motion, the word primary may be used in several senses. A thing is said to be prior to other things when, if it does not exist, the others will not exist, whereas it can exist without the others. And there is also priority in time and priority in perfection of existence. Let us begin, then, with the first sense. Now there must be motion continuously, and there may be continuously either continuous motion or successive motion, the former, however, in a higher degree than the latter. Moreover, it is better that it should be continuous rather than successive motion, and we always assume the presence in nature of the better, if it be possible. Since, then, continuous motion is possible, this will be proved later. For the present, let us take it for granted, and no other motion can be continuous except locomotion. Locomotion must be primary. For there is no necessity for the subject of locomotion to be the subject either of increase or of alteration, nor need it become or perish. On the other hand, there cannot be any one of these processes without the existence of the continuous motion imparted by the first movement. Secondly, locomotion must be primary in time, for this is the only motion possible for things. It is true indeed that, in the case of any individual thing that has a becoming, locomotion must be the last of its motions, for after its becoming it first experiences alteration and increase, and locomotion is a motion that belongs to such things only when they are perfected. But there must previously be something else that is in process of locomotion to be the cause even of the becoming of things that become, without itself being in process of becoming. As, for example, the begotten is preceded by what begot it. Otherwise, becoming might be thought to be the primary motion on the ground that the thing must first become. But though this is so in the case of any individual thing that becomes, nevertheless, before anything becomes, something else must be in motion, not itself becoming, but being, and before this there must again be something else. And since becoming cannot be primary, for if it were, everything that is in motion would be perishable, it is plain that no one of the motions next in order can be prior to locomotion. By the motions next in order, I mean increase and then alteration, decrease, and perishing. All these are posterior to becoming. Consequently, if not even becoming is prior to locomotion, then no one of the other processes of change is so either. Thirdly, that which is in process of becoming appears universally as something imperfect and proceeding to a first principle. And so what is posterior in the order of becoming is prior in the order of nature. Now, all things that go through the process of becoming acquire locomotion last. It is this that accounts for the fact that some living things, for example plants and many kinds of animals, owing to lack of the requisite organ, are entirely without motion, whereas others acquire it in the course of their being perfected. Therefore, if the degree in which things possess locomotion corresponds to the degree in which they have realized their natural development, then this motion must be prior to all others in respect of perfection of existence. And not only for this reason, but also because a thing that is in motion loses its essential character less in the process of locomotion than in any other kind of motion. It is the only motion that does not involve a change of being, in the sense in which there is a change in quality when a thing is altered and a change in quantity when a thing is increased or decreased. Above all, it is plain that this motion in respect of place, is what is in the strictest sense produced by that which moves itself, but it is the self-movement that we declare to be the first principle of things that are moved, and impart motion and the primary source to which things that are in motion are to be referred. It is clear then from the foregoing arguments that locomotion is the primary motion. We have now to show which kind of locomotion is primary. The same process of reasoning will also make clear at the same time the truth of the assumption we have made both now and at a previous stage that it is possible that there should be a motion that is continuous and eternal. Now, it is clear from the following considerations that no other than locomotion can be continuous. Every other motion and change is from an opposite to an opposite. Thus, for the processes of becoming and perishing, the limits are the existent and the non-existent. For alteration, the various pairs of contrary affections, and for increase and decrease, either greatness and smallness, or perfection and imperfection of magnitude. And changes to the respective contraries are contrary changes. Now, a thing that is undergoing any particular kind of motion, but though previously existent has not always undergone it, must previously have been at rest so far as that motion is concerned. It is clear, then, that for the changing thing the contraries will be states of rest. And we have a similar result in the case of changes that are not motions, for becoming and perishing, whether regarded simply as such without qualification or as affecting something in particular, are opposites. Therefore, provided it is impossible for a thing to undergo opposite changes at the same time, the change will not be continuous, but a period of time will intervene between the opposite processes. The question whether these contradictory changes are contraries or not makes no difference, provided only it is impossible for them both to be present to the same thing at the same time. The point is of no importance to the argument. Nor does it matter if the thing need not rest in the contradictory state, or if there is no state of rest as a contrary to the process of change. It may be true that the non-existent is not at rest, and that perishing is a process to the non-existent. All that matters is the intervention of a time. It is this that prevents the change from being continuous. So, too, in our previous instances, the important thing was not the relation of contrariety, but the impossibility of the two processes being present to a thing at the same time. And there is no need to be disturbed by the fact that on this showing there may be more than one contrary to the same thing, that a particular motion will be contrary both to rest and to motion in the contrary direction. We have only to grasp the fact that a particular motion is in a sense the opposite both of a state of rest and of the contrary motion, in the same way as that which is of equal or standard measure is the opposite both of that which surpasses it and of that which it surpasses, and that it is impossible for the opposite motions or changes to be present to a thing at the same time. Furthermore, in the case of becoming and perishing, it would seem to be an utterly absurd thing if as soon as anything has become it must necessarily perish, and cannot continue to exist for any time, and, if this is true of becoming and perishing, we have fair grounds for inferring the same to be true of the other kinds of change, since it would be in the natural order of things that they should be uniform in this respect. Section 8. Let us now proceed to maintain that it is possible that there should be an infinite motion that is single and continuous, and that this motion is rotatory motion. The motion of everything that is in process of locomotion is either rotatory or rectilinear, or a compound of the two. Consequently, if one of the former two is not continuous, that which is composed of them both cannot be continuous either. Now, it is plain that if the locomotion of a thing is rectilinear and finite, it is not continuous locomotion, for the thing must turn back, and that which turns back in a straight line undergoes two contrary locomotions, since, so far as motion in respect of place is concerned, upward motion is the contrary of downward motion, forward motion of backward motion, and motion to the left of motion to the right, these being the pairs of contraries in the sphere of place. But we have already defined single and continuous motion to be motion of a single thing in a single period of time, and operating within a sphere admitting of no further specific differentiation, for we have three things to consider. First, that which is in motion, for example, a man or a god. Secondly, the when of the motion, that is to say, the time. And thirdly, the sphere within which it operates, which may be either place or affection, or essential form or magnitude. And contraries are specifically not one and the same, but distinct, and within the sphere of place we have the above-mentioned distinctions. Moreover, we have an indication that motion from A to B is the contrary of motion from B to A, in the fact that, if they occur at the same time, they arrest and stop each other. And the same is true in the case of a circle. The motion from A towards B is the contrary of the motion from A towards G. For even if they are continuous and there is no turning back, they arrest each other, because contraries annihilate or obstruct one another. On the other hand, lateral motion is not the contrary of upward motion. But what shows most clearly that rectilinear motion cannot be continuous is the fact that turning back necessarily implies coming to a stand, not only when it is a straight line that is traversed, but also in the case of locomotion in a circle, which is not the same thing as rotatory locomotion. For when a thing merely traverses a circle, it may either proceed on its course without a break, or turn back again when it has reached the same point from which it started. We may assure ourselves of the necessity of this coming to a stand not only on the strength of observation, but also on theoretical grounds. We may start as follows. We have 3 points: starting point, middle point, and finishing point, of which the middle point, in virtue of the relations in which it stands severally to the other 2, is both a starting point and a finishing point, and though numerically 1, is theoretically 2. We have, further, the distinction between the potential and the actual. So in the straight line in question, any one of the points lying between the 2 extremes is potentially a middle point. But it is not actually so unless that which is in motion divides the line by coming to a stand at that point and beginning its motion again. Thus the middle point becomes both a starting point and a goal, the starting point of the latter part and the finishing point of the first part of the motion. This is the case, for example, when A, in the course of its locomotion, comes to a stand at B and starts again towards G. But when its motion is continuous, A cannot either have come to B or have ceased to be at the point B. It can only have been there at the moment of passing, its passage not being contained within a period of time, except the whole of which the particular moment is a dividing point. To maintain that it has come to be and ceased to be there will involve the consequence that A, in the course of its locomotion, will always be coming to a stand. For it is impossible that A should simultaneously have come to be at B and ceased to be there, so that the 2 things must have happened at different points of time, and therefore there will be the intervening period of time. Consequently, A will be in a state of rest at B, and similarly at all other points, since the same reasoning holds good in every case. When to A, that which is in process of locomotion, B, the middle point serves both as a finishing point and as a starting point for its motion. A must come to a stand at B, because it makes it 2 just as one might do in thought. However, the point A is the real starting point at which the moving body has ceased to be, and it is at G that it has really come to be when its course is finished and it comes to a stand. So this is how we must meet the difficulty that then arises, which is as follows. Suppose the line E is equal to the line Z, that A proceeds in continuous locomotion from the extreme point of E to G, and that at the moment when A is at the point B, D is proceeding in uniform locomotion and with the same velocity as A from the extremity of Z to H. Then, says the argument, D will have reached H before A has reached G, for that which makes an earlier start and departure must make an earlier arrival. The reason, then, for the late arrival of A is that it has not simultaneously come to be and ceased to be at B. Otherwise, it will not arrive later. For this to happen, it will be necessary that it should come to a stand there. Therefore, we must not hold that there was a moment when A came to be at B, and that at the same moment D was in motion from the extremity of Z, for the fact of A's having come to be at B will involve the fact of its also ceasing to be there, and the 2 events will not be simultaneous, whereas the truth is that A is at B at a sectional point of time and does not occupy time there. In this case, therefore, where the motion of a thing is continuous, it is impossible to use this form of expression. On the other hand, in the case of a thing that turns back in its course, we must do so. For suppose H, in the course of its locomotion, proceeds to D, and then turns back and proceeds downwards again. Then the extreme point D has served as finishing point and as starting point for it, 1 point thus serving as 2. Therefore, H must have come to a stand there. It cannot have come to be at D and departed from D simultaneously, for in that case it would simultaneously be there and not be there at the same moment. and here we cannot apply the argument used to solve the difficulty stated above. We cannot argue that h is at D at a sectional point of time and has not come to be or ceased to be there. For here the goal that is reached is necessarily one that is actually, not potentially, existent. Now, the point in the middle is potential, but this one is actual, and regarded from below, it is a finishing point, while regarded from above, it is a starting point, so that it stands in these same two respective relations to the two motions. Therefore, that which turns back in traversing a rectilinear course must in so doing come to a stand. Consequently, there cannot be a continuous rectilinear motion that is eternal. The same method should also be adopted in replying to those who ask, in the terms of Zeno's argument, whether we admit that before any distance can be traversed, half the distance must be traversed, that these half-distances are infinite in number, and that it is impossible to traverse distances infinite in number, or some on the lines of this same argument put the question to another form, and would have us grant that in the time during which a motion is in progress, it should be possible to reckon a half-motion before the whole for every half-distance that we get, so that we have the result that when the whole distance is traversed, we have reckoned an infinite number, which is admittedly impossible. Now, when we first discussed the question of motion, we put forward a solution of this difficulty, turning on the fact that the period of time occupied in traversing the distance contains within itself an infinite number of units. There is no absurdity, we said, in supposing the traversing of infinite distances in infinite time, and the element of infinity is present in the time no less than in the distance. But although this solution is adequate as a reply to the questioner, the question asked being whether it is possible in a finite time to traverse or reckon an infinite number of units, nevertheless, as an account of the fact and explanation of its true nature, it is inadequate. For suppose the distance to be left out of account, and the question asked to be no longer whether it is possible in a finite time to traverse an infinite number of distances, and suppose that the inquiry is made to refer to the time taken by itself, for the time contains an infinite number of divisions, then this solution will no longer be adequate, and we must apply the truth that we enunciated in our recent discussion, stating it in the following way. In the act of dividing the continuous distance into two halves, one point is treated as two, since we make it a starting point and a finishing point, and this same result is also produced by the act of reckoning halves as well as by the act of dividing into halves. But, if divisions are made in this way, neither the distance nor the motion will be continuous. For motion, if it is to be continuous, must relate to what is continuous. And though what is continuous contains an infinite number of halves, there are not actual but potential halves. If the halves are made actual, we shall not get a continuous but an intermittent motion. In this case of reckoning the halves, it is clear that this result follows. For then one point must be reckoned as two. It will be the finishing point of the one half and the starting point of the other, if we reckon not the one continuous whole, but the two halves. Therefore, to the question whether it is possible to pass through an infinite number of units, either of time or of distance, we must reply that in a sense it is, and in a sense it is not. If the units are actual, it is not possible. If they are potential, it is possible. For in the course of a continuous motion, the traveler has traversed an infinite number of units in an accidental sense, but not in an unqualified sense. For though it is an accidental characteristic of the distance to be an infinite number of half-distances, this is not its real and essential character. It is also plain that unless we hold that the point of time that divides earlier from later always belongs only to the later, so far as the thing is concerned, we shall be involved in the consequence that the same thing is at the same moment existent and not existent, and that a thing is not existent at the moment when it has become. It is true that the point is common to both times, the earlier as well as the later, and that, while numerically one and the same, it is theoretically not so, being the finishing point of the one and the starting point of the other. But so far as the thing is concerned, it belongs to the later stage of what happens to it. Let us suppose a time, A, B, G, and a thing, D, D being white in the time A, and not white in the time B. Then D is at the moment G white and not white. For if we were right in saying that it is white during the whole time A, it is true to call it white at any moment of A, and not white in B, and G is in both A and B. We must not allow, therefore, that it is white in the whole of A, but must say that it is so in all of it except the last moment G. G belongs already to the later period, and, if in the whole of A not white was in process of becoming and white of perishing, at G the process is complete. And so G is the first moment at which it is true to call the thing white or not white respectively. Otherwise, a thing may be non-existent at the moment when it has become, and existent at the moment when it has perished. Or else it must be possible for a thing at the same time to be white and not white, and in fact to be existent and non-existent. Further, if anything that exists after having been previously non-existent must become existent and does not exist when it is becoming, time cannot be divisible into time atoms. For suppose that D was becoming white in the time A, and that at another time, B, a time atom consecutive with the last atom of A, D has already become white, and so is white at that moment. Then, inasmuch as in the time A it was becoming white, and so is not white, and at the moment B it is white, there must have been a becoming between A and B, and therefore also a time in which the becoming took place. On the other hand, those who deny atoms of time, as we do, are not affected by this argument. According to them, D has become, and so is white at the last point of the actual time in which it was becoming white. And this point has no other point consecutive with or in succession to it, whereas time atoms are conceived as successive. Moreover, it is clear that if D was becoming white in the whole time A, the time occupied by it in having become white, in addition to having been in process of becoming white, is no more than all than it occupied in the mere process of becoming white. These and such like, then, are the arguments for our conclusion that derive cogency from the fact that they have a special bearing on the point at issue. If we look at the question from the point of view of general theory, the same result would also appear to be indicated by the following arguments. Everything whose motion is continuous must, on arriving at any point in the course of its locomotion, have been previously also in process of locomotion to that point, if it is not forced out of its path by anything. For example, on arriving at B, a thing must also have been in process of locomotion to B, and that not merely when it was near to B, but from the moment of its starting on its course, since there can be no reason for its being so at any particular stage rather than at an earlier one. So too, in the case of the other kinds of motion. Now we are to suppose that a thing proceeds in locomotion from A to G, and that at the moment of its arrival at G, the continuity of its motion is unbroken and will remain so until it has arrived back at A. Then, when it is undergoing locomotion from A to G, it is at the same time undergoing also its locomotion to A from G. Consequently, it is simultaneously undergoing two contrary motions, since the last two motions that follow the same straight line are contrary to each other. Within this consequence there also follows another. We have a thing that is in process of change from a position in which it has not yet been. So, inasmuch as this is impossible, the thing must come to a stand at G. Therefore, the motion is not a single motion, since motion that is interrupted by stationariness is not single. Further, the following argument will serve better to make this point clear universally in respect of every kind of motion. If the motion undergone by that which is in motion is always one of those already enumerated, and the state of rest that it undergoes is one of those that are the opposites of the motions, for we found that there could be no other besides these, and moreover that which is undergoing but does not always undergo a particular motion, by this I mean one of the various specifically distinct motions, not some particular part of the whole motion, must have been previously undergoing the state of rest that is the opposite of the motion, the state of rest being privation of motion. Then, inasmuch as the two motions that follow the same straight line are contrary motions, and it is impossible for a thing to undergo simultaneously two contrary motions, that which is undergoing locomotion from A to G cannot also simultaneously be undergoing locomotion from G to A. And since the latter locomotion is not simultaneous with the former, but is still to be undergone, before it is undergone there must occur a state of rest at G. For this, as we found, is the state of rest that is the opposite of the motion from G. The foregoing argument, then, makes it plain that the motion in question is not continuous. Our next argument has a more special bearing than the foregoing on the point at issue. We will suppose that there has occurred in something simultaneously a perishing of not white and a becoming of white. Then, if the alteration to white and from white is a continuous process and the white does not remain any time, there must have occurred simultaneously a perishing of not white, a becoming of white, and a becoming of not white, for the time of the three will be the same. Again, from the continuity of the time in which the motion takes place, we cannot infer continuity in the motion, but only successiveness. In fact, how could contraries, that is, whiteness and blackness, meet in the same extreme point? On the other hand, in motion on a circular line, we shall find singleness and continuity, for here we are met by no impossible consequence. That which is in motion from A will, in virtue of the same direction of energy, be simultaneously in motion to A, since it is in motion to the point at which it will finally arrive, and yet will not be undergoing two contrary or opposite motions. For a motion to a point and a motion from that point are not always contraries or opposites. They are contraries only if they are on the same straight line, for then they are contrary to one another in respective place, as, for example, the two motions along the diameter of the circle, since the ends of this are at the greatest possible distance from one another, and they are opposites only if they are along the same line. Therefore, in the case we are now considering, there is nothing to prevent the motion being continuous and free from all intermission. For rotatory motion is motion of a thing from its place to its place, whereas rectilinear motion is motion from its place to another place. Moreover, the progress of rotatory motion is never localized within certain fixed limits, whereas that of rectilinear motion repeatedly is so. Now, a motion that is always shifting its ground from moment to moment can be continuous, but a motion that is repeatedly localized within certain fixed limits cannot be so, since then the same thing would have to undergo simultaneously two opposite motions. So, too, there cannot be continuous motion in a semicircle or in any other arc of a circle, since here also the same ground must be traversed repeatedly and two contrary processes of change must occur. The reason is that in these motions the starting point and the termination do not coincide, whereas in motion over a circle they do coincide, and so this is the only perfect motion. This differentiation also provides another means of showing that the other kinds of motion cannot be continuous either. For in all of them we find that there is the same ground to be traversed repeatedly. Thus, in alteration there are the intermediate stages of the process, and in quantitative change there are the intervening degrees of magnitude, and in becoming and perishing the same thing is true. It makes no difference whether we take the intermediate stages of the process to be few or many, or whether we add or subtract one, for in either case we find that there is still the same ground to be traversed repeatedly. Moreover, it is plain from what has been said that those physicists who assert that all sensible things are always in motion are wrong, for their motion must be one or other of the motions just mentioned. In fact, they mostly conceive it as alteration. Things are always in flux and decay, they say, and they go so far as to speak even of becoming and perishing as a process of alteration. On the other hand, our argument has enabled us to assert the fact, applying universally to all motions, that no motion admits of continuity except rotatory motion. Consequently, neither alteration nor increase admits of continuity. We need now say no more in support of the position that there is no process of change that admits of infinity or continuity except rotatory locomotion. Section 9. It can now be shown plainly that rotation is the primary locomotion. Every locomotion, as we said before, is either rotatory or rectilinear or a compound of the two, and the two former must be prior to the last, since they are the elements of which the latter consists. Moreover, rotatory locomotion is prior to rectilinear locomotion because it is more simple and complete, which may be shown as follows. The straight line traversed in rectilinear motion cannot be infinite, for there is no such thing as an infinite straight line, and even if there were, it would not be traversed by anything in motion, for the impossible does not happen, and it is impossible to traverse an infinite distance. On the other hand, rectilinear motion on a finite straight line is, if it turns back, a composite motion, in fact, two motions, while if it does not turn back, it is incomplete and perishable. And in the order of nature, of definition, and of time alike, the complete is prior to the incomplete, and the imperishable to the perishable. Again, a motion that admits of being eternal is prior to one that does not. Now, rotatory motion can be eternal, but no other motion, whether locomotion or motion of any other kind, can be so, since in all of them rest must occur, and with the occurrence of rest, the motion has perished. Moreover, the result at which we have arrived, that rotatory motion is single and continuous, and rectilinear motion is not, is a reasonable one. In rectilinear motion, we have a definite starting point, finishing point, middle point, which all have their place in it in such a way that there is a point from which that which is in motion can be said to start, and a point at which it can be said to finish its course, for when anything is at the limits of its course, whether at the starting point or at the finishing point, it must be in a state of rest. On the other hand, in circular motion, there are no such definite points, for why should any one point on the line be a limit rather than any other? Any one point, as much as any other, is alike starting point, middle point, and finishing point, so that we can say of certain things both that they are always and that they are never, at a starting point and at a finishing point, so that a revolving sphere, while it is in motion, is also in a sense at rest, for it continues to occupy the same place. The reason of this is that in this case all these characteristics belong to the center. That is to say, the center is alike starting point, middle point, and finishing point of the space traversed. Consequently, since this point is not a point on the circular line, there is no point at which that which is in process of locomotion can be in a state of rest as having traversed its course, because in its locomotion it is proceeding always about a central point and not to an extreme point. Therefore it remains still, and the whole is in a sense always at rest as well as continuously in motion. Our next point gives a convertible result. On the one hand, because rotation is the measure of motions, it must be the primary motion, for all things are measured by what is primary. On the other hand, because rotation is the primary motion, it is the measure of all other motions. Again, rotatory motion is also the only motion that admits of being regular. In rectilinear locomotion, the motion of things in leaving the starting point is not uniform with their motion in approaching the finishing point, since the velocity of a thing always increases proportionately as it removes itself farther from its position of rest. On the other hand, rotatory motion is the only motion whose course is naturally such that it has no starting point or finishing point in itself, but is determined from elsewhere. As to locomotion being the primary motion, this is a truth that is attested by all who have ever made mention of motion in their theories. They all assign their first principles of motion to things that impart motion of this kind. Thus, separation and combination are motions in respective place, and the motion imparted by love and strife take these forms, the latter separating and the former combining. Anaxagoras, too, says that mind, his first movement, separates. Similarly, those who assert no cause of this kind, but say that void accounts for motion, they also hold that the motion of natural substance is motion in respective place. For their motion that is accounted for by void is locomotion, and its sphere of operation may be said to be place. Moreover, they are of opinion that the primary substances are not subject to any of the other motions, though the things that are compounds of these substances are so subject. The processes of increase and decrease and alteration, they say, are effects of the combination and separation of atoms. It is the same, too, with those who make out that the becoming or perishing of a thing is accounted for by density or rarity. For it is by combination and separation that the place of these things in their systems is determined. Moreover, to these we may add those who make soul the cause of motion, for they say that things that undergo motion have as their first principle that which moves itself, and when animals and all living things move themselves, the motion is motion in respective place. Finally, it is to be noted that we say that a thing is in motion in the strict sense of the term only when its motion is motion in respective place. If a thing is in process of increase or decrease, or is undergoing some alteration while remaining at rest in the same place, we say that it is in motion in some particular respect. We do not say that it is in motion without qualification. Our present position, then, is this. We have argued that there always was motion and always will be motion throughout all time, and we have explained what is the first principle of this eternal motion. We have explained further which is the primary motion and which is the only motion that can be eternal, and we have pronounced the first movement to be unmoved. Section 10. We have now to assert that the first movement must be without parts and without magnitude, beginning with the establishment of the premises on which this conclusion depends. One of these premises is that nothing finite can cause motion during an infinite time. We have three things: the movement, the moved, and thirdly, that in which the motion takes place, namely the time. And these are either all infinite or all finite, or partly, that is to say, two of them or one of them finite and partly infinite. Let A be the movement, B the moved, and G the infinite time. Now let us suppose that D moves E, a part of B. Then the time occupied by this motion cannot be equal to G, for the greater the amount moved, the longer the time occupied. It follows that the time Z is not infinite. Now we see that by continuing to add to D, I shall use up A, and by continuing to add E, I shall use up B. But I shall not use up the time by continually subtracting a corresponding amount from it, because it is infinite. Consequently, the duration of the part of G, which is occupied by all A in moving the whole of B, will be finite. Therefore, a finite thing cannot impart to anything an infinite motion. It is clear, then, that it is impossible for the finite to cause motion during an infinite time. It is now to be shown that in no case is it possible for an infinite force to reside in a finite magnitude. This can be shown as follows. We take it for granted that the greater force is always that which in less time than another does an equal amount of work when engaged in any activity, in heating, for example, or sweetening or throwing. In fact, in causing any kind of motion. Then that on which the forces act must be affected to some extent by our supposed finite magnitude possessing an infinite force as well as by anything else. In fact, to a greater extent than by anything else, since the infinite force is greater than any other. But then there cannot be any time in which its action could take place. Suppose that A is the time occupied by the infinite power in the performance of an act of heating or pushing, and that AB is the time occupied by a finite power in the performance of the same act. Then by adding to the latter another finite power and continually increasing the magnitude of the power so added, I shall at some time or other reach a point at which the finite power has completed the motive act in the time A. For by continual addition to a finite magnitude, I must arrive at a magnitude that exceeds any assigned limit, and in the same way, by continual subtraction, I must arrive at one that falls short of any assigned limit. So we get the result that the finite force will occupy the same amount of time in performing the motive act as the infinite force. But this is impossible. Therefore, nothing finite can possess an infinite force. So it is also impossible for a finite force to reside in an infinite magnitude. It is true that a greater force can reside in a lesser magnitude, but the superiority of any such greater force can be still greater if the magnitude in which it resides is greater. Now let AB be an infinite magnitude. Then BG possesses a certain force that occupies a certain time, let us say the time Z, in moving D. Now, if I take a magnitude twice as great at BG, the same time occupied by this magnitude in moving D will be half of EZ, assuming this to be the proportion. So we may call this time ZH. That being so, by continually taking a greater magnitude in this way, I shall never arrive at the full AB, whereas I shall always be getting a lesser fraction of the time given. Therefore, the force must be infinite, since it exceeds any finite force. Moreover, the time occupied by the action of any finite force must also be finite. For if a given force moves something in a certain time, a greater force will do so in a lesser time, but still a definite time in inverse proportion. But a force must always be infinite, just as a number or a magnitude is, if it exceeds all definite limits. This point may also be proved in another way, by taking a finite magnitude in which there resides a force the same in kind as that which resides in the infinite magnitude, so that this force will be a measure of the finite force residing in the infinite magnitude. It is plain, then, from the foregoing arguments, that it is impossible for an infinite force to reside in a finite magnitude, or for a finite force to reside in an infinite magnitude. But before proceeding to our conclusion, it will be well to discuss a difficulty that arises in connection with locomotion. If everything that is in motion, with the exception of things that move themselves, is moved by something else, how is it that some things, for example, things thrown, continue to be in motion when their movement is no longer in contact with them? If we say that the movement in such cases moves something else at the same time, that the thrower, for example, also moves the air, and that this, in being moved, is also a movement, then it would be no more possible for this second thing than for the original thing to be in motion when the original movement is not in contact with it or moving it. All the things moved would have to be in motion simultaneously, and also have to have ceased simultaneously to be in motion when the original movement ceases to move them, even if, like the magnet, it makes that which it has moved capable of being a movement. Therefore, while we must accept this explanation to the extent of saying that the original movement gives the power of being a movement, either to air or to water, or to something else of the kind, naturally adapted for imparting and undergoing motion, we must say further that this thing does not cease simultaneously to impart motion and to undergo motion. It ceases to be in motion at the moment when its movement ceases to move it, but it still remains a movement, and so it causes something else consecutive with it to be in motion, and of this again the same may be said. The motion begins to cease when the motive force produced in one member of the consecutive series is at each stage less than that possessed by the preceding member, and it finally ceases when one member no longer causes the next member to be a movement, but only causes it to be in motion. The motion of these last two, of the one as movement and of the other as moved, must cease simultaneously, and with this the whole motion ceases. Now, the things in which this motion is produced are things that admit of being sometimes in motion and sometimes at rest, and the motion is not continuous but only appears so, for it is motion of things that are either successive or in contact, there being not one movement but a number of movements consecutive with one another, and so motion of this kind takes place in air and water. Some say that it is mutual replacement, but we must recognize that the difficulty raised cannot be solved otherwise than in the way we have described. So far as they are affected by mutual replacement, all the members of the series are moved and impart motion simultaneously, so that their motions also cease simultaneously. But our present problem concerns the appearance of continuous motion in a single thing, and therefore, since it cannot be moved throughout its motion by the same movement, the question is, what moves it? Resuming our main argument, we proceed from the positions that there must be continuous motion in the world of things, that this is a single motion, that a single motion must be a motion of a magnitude, for that which is without magnitude cannot be in motion, and that the magnitude must be a single magnitude moved by a single movement, for otherwise there will not be continuous motion, but a consecutive series of separate motions, and that if the movement is a single thing, it is either itself in motion or itself unmoved. If, then, it is in motion, it will have to be subject to the same conditions as that which it moves. That is to say, it will itself be in process of change, and in being so, will also have to be moved by something. So, we have a series that must come to an end, and a point will be reached at which motion is imparted by something that is unmoved. Thus we have a movement that has no need to change along with that which it moves, but will be able to cause motion always, for the causing of motion under these conditions involves no effort, and this motion alone is regular, or at least it is so in a higher degree than any other, since the movement is never subject to any change. So, too, in order that the motion may continue to be of the same character, the moved must not be subject to change in respect of its relation to the movement. Moreover, the movement must occupy either the center or the circumference, since these are the first principles from which a sphere is derived. But the things nearest the movement are those whose motion is quickest, and in this case it is the motion of the circumference that is the quickest. Therefore, the movement occupies the circumference. There is a further difficulty in supposing it to be possible for anything that is in motion to cause motion continuously, and not merely in the way in which it is caused by something repeatedly pushing, in which case the continuity amounts to no more than successiveness. Such a movement must either itself continue to push or pull or perform both these actions, or else the action must be taken up by something else and be passed on from one movement to another. The process that we described before as occurring in the case of things thrown, since the air or the water being divisible is a movement only in virtue of the fact that different parts of the air are moved one after another. And in either case the motion cannot be a single motion, but only a consecutive series of motions. The only continuous motion, then, is that which is caused by the unmoved movement. And this motion is continuous because the movement remains always invariable, so that its relation to that which it moves remains also invariable and continuous. Now that these points are settled, it is clear that the first unmoved movement cannot have any magnitude. For if it has magnitude, this must be either a finite or an infinite magnitude. Now, we have already proved in our course on physics that there cannot be an infinite magnitude, and we have now proved that it is impossible for a finite magnitude to have an infinite force, and also that it is impossible for a thing to be moved by a finite magnitude during an infinite time. But the first movement causes a motion that is eternal and does cause it during an infinite time. It is clear, therefore, that the first movement is indivisible and is without parts and without magnitude. The end of Book 8 and the end of Physics by Aristotle. Read by Rick Kishner for Lit2Go on the web at fcit.usf.edu.